Hello KMA Land, I'm Bob Peterson, the Industrial Technology Instructor here at Red Oak High School. We're starting the first in our series of monthly interviews where you're going to come and look at different classes and programs that we offer here at Red Oak Industrial Technology. We are currently out here in our lab, our production lab, largely because during class time with the new renovations and stuff going on at the high school, a lot of the teachers have had to come over to the tech center where we're located. So as a result of that, I am sharing my classroom in the morning, so I'm holding a lot of my classes out here, and electricity happens to be one of them. So we're going to visit with several of the individuals that are in class and see a couple things that they've been doing here at the start of the year. We're just about 3 weeks into it, so it's been very introductory and fundamental to get started with. So we'll come over here. We'll start with, go ahead and introduce yourself.
Noah Westerland. I'm a junior here at Red Oak High School.
Okay. And?
I'm Kale Schmedke, and I'm a sophomore here at Red Oak High School.
Okay. So we've been studying Conductors and Insulators is our most recent unit. So they've done a few basic lab activities, and they're going to tell us about the one they've been working on here. So we've been doing Conductors and Insulators. Which have you guys been looking at?
We're looking at insulators right now. We're using the multimeter here, and what it does is it puts a current. It'll put a current through whatever the two ends are touching, and it'll tell whether it conducts electricity or whether it obviously doesn't. And with a good insulator, you want it to not conduct electricity.
Okay. So what were your results what different materials do you have here to use as insulators?
This one here, we tested rubber. This is a Romex cover that would be over wiring like in your house. And then this is just plastic. And all of them were good insulators. They showed that if it tests at 0 ohms, that's the scale we use as ohms. If it's 0, then it's a good conductor, and then if it's up here in the 1,000, 2,000, all the way up to 10,000, that means that it's a poor conductor of electricity, and that's what you want when you're working with insulators.
We're here now with, go ahead and introduce yourself.
I'm Jarrett Maines. I'm a senior here at Red Oak High School.
Okay. And we just got done looking at insulators, and so you were looking at what material here?
Conductors. We have aluminum, copper, and steel. And the way you test this is you take your multimeter that Noah just introduced to you, and you put your ends together, and if it's a good conductor, it'll go down to 0. And this is a fairly good conductor.
Okay. Which material is that?
This is aluminum.
And how did most of your materials turn out when you did that test on them?
They were all pretty much good conductors, steel being probably the best, and copper being second.
Okay. So real good materials for things like conductors, like wires that we need, and the steel, of course, with frames and things like that for automobiles that have to create a ground or something for that system. Besides insulators and conductors, we've been looking at types of conductors, which were a lot of different wires and things like that. So here we've been looking at a couple different wires, and Wyatt's going to tell us about that.
Hello, I'm Wyatt Cedarberg, and I'm a junior here at Red Oak High School.
Okay. So you've been looking at a couple different wires, and they were different sizes. What kind of things have you been looking at with those wires?
The thickness of the wires in it, what we're looking at here is stranded wires. As you can see, there's multiple little wires put into it. So this one's a lot thicker in the wire, so it's harder for it to bend. It has 19 wires total in it. Well, this smaller one has 19 wires total in it too, but the wiring in it is smaller so it can bend more properly for it to get around corners and things. And this one only has 7, but since it has 7, it may not conduct as much electricity.
Okay, so we were looking at it's being stranded as opposed to what would be, if it wasn't stranded, what kind of wire would it be?
It would be called solid, so it'd just be one thicker wire.
Okay. Which, of course, then wouldn't bend very well and would be harder to work with. So we've been looking at conductors and insulators, and part of the working with conductors is actually attaching them or connecting them to things that you need to work with or power. And one of the ways that we can do that is through soldering. So just today, actually, the students started a little soldering exercise where they're getting a little practice. And Noah and Jarrett are going to explain a little bit about the steps they have to go through in order to start off getting a solder joint.
So today we were practicing doing soldering joints, and in class what we did was we cut off a piece of wire that's about 5 to 6 inches long, and we cut that in half, and then we take our wire strippers, we strip the insulation off of the wire so we get the bare wire on the inside of the insulation. And then we twist the wires together, and then we get our soldering iron plugged in here and get it heating up while we're doing all this. And once it's hot, we go ahead and we've got our wires twisted together. We lay our wires on the soldering iron, start getting the wires hot, and we take our solder here and we just slowly move it back and forth and let the solder melt and fill in the cracks and stuff in between the two wires that are twisted together, and then that'll create your solder joint, and your wires are attached together and electricity will flow through them good now.
Okay, good. Jarrett, if we wanted to know what a good soldered joint would look like, how should it appear if we were looking at one?
It should look shiny and smooth.
Okay, so shiny and smooth means that we've got enough heat put into it, so we have a good adherence to the materials and stuff. So that kind of wraps it up for us today here at Red Oak High School Industrial Technology Program. Our first in the series of monthly meetings that we're going to have. So we'll look forward to getting to visit with you each month now through the rest of the school year, and also maybe get a few updates on how our construction projects are going. So for the electricity students here at Red Oak High School and myself and KMA, thank you for watching.